Welcome to the Vision Brick. In this video, I will show you how to track objects using Lucas-Kanade Optical Flow method in OpenCV. Let me show you a few examples before starting. Yeah, you see the path. And I want to show you one example with code. So first step will be, we will draw a rectangle around our target object. You see in this case, plane is our target object. So I will draw a rectangle like this with my mouse right button. Okay, nice. Oh, let me copy second cell. And in this step, we will detect corners with Harris corner detection. And we will choose one specific corner point, and you can see this red circle in this case. And we will try to track this specific point in each frame. And this will happen in third step, final step. So we will try to track this red, not this red one, because I draw this red, but there is some feature here. We will try to track this. Okay, let me show you. Yeah, you can see the path and FPS values. Yeah, it's perfect. You see, we are following the same feature. Oh, let me show you that again. You see, this feature is same with this one. You see, and when object is disappear, it choose new point and it tries to track new point. But of course, you can adjust this code. But now I can delete these cells, and I think I can start. Yeah, I will share a link to do this article in comment section. You can find all of the code. Or if you prefer reading, you can read this article or watch the video, it's up to you. But we basically have three main steps. Now let me explain you step number one, and before that you need to install few libraries. You can install it with pip. You see you need three main libraries. I already have, and you see I have three test video. I will show you I will test with every video, but for now I will use this one, plane 2. Okay, so basically first step is really simple. We are reading our video, and by using coordinate chooser function, we are drawing rectangle and we are saving those coordinates of rectangle. You see we have 4 coordinates. Yeah, you can see this is our target object. I am drawing rectangle by using right button of my mouse. You see the coordinates are saved. Actually, let me print those. Oops. Yes. So you see these are coordinates of rectangle. So this 2 is top left and last 2 is bottom right. Yeah, we can continue. So this is the second step. Here we will detect corners. Actually, we will detect corners from rectangle. Remember, we just drew it. Let me show you. Yeah, you see. Let me show you that. Where is this? Here. First, you see this is our region of interest. And you can see 4 coordinates of rectangles. We are converting it to grayscale. You can see here. And here we will use good features to track, and that means that it is Harris corner detection. It has few parameters like maximum number of corners, quality level, minimum distance between detected points. Of course, you can change these values. We will use this first gray frame later. I will explain it. And here we are detecting corners from full frame. This is our full frame, not only selected rectangle. And we are looping through points. And if detected corner point falls between rectangle's coordinate inside this rectangle, we are saving this point. You see selected point. If it is inside of the rectangle, we are saving that, and here we are drawing it. You see, we will try to track this specific point. Yeah, I think it's not that complex. Basically, we are detecting corners from full frame. After that, if some point is inside of that specific rectangle, we are saving it because we will try to track it for every frame. And in this case, our point is here. Yes, we can continue. And this is, oh sorry, this is last step. Yeah, here these are parameters of Lucas-Kanade Optical Flow method. You can read this explanation of parameters, window size, max level, and criteria. Here we are reading our video, width and height values, and we have some mask. We will use this mask for drawing the paths. And these are for FPS calculation. You don't have to understand these. So we are reading video, we have while loop, reading video, and we are converting it to grayscale because most of the algorithms in computer vision works with grayscale images and optical flow as well. And if we have points, we are calculating the position of other point. Yeah, it's a little bit complex, but you can see the explanation of parameters. So basically, optical flow method expects these parameters. First one is old image, and second one is new image. So basically, we are using old image and old image coordinates for calculating coordinates of new point. And you see, we have P0, and this P0 is this one. We are using this to calculate new position of this corner point in other frame, and it returns P1. This is our new point. And you can see this is our old point and this is our new point. And if we found new point, we are saving these coordinates again. Good old points and new points. We are saving those because we will draw lines between new point and old point. So by doing that, we will see some paths. You see, if you connect this old point and new point, it will be like, look at my mouse, it will be like this. So it will be some kind of path. You can see we are drawing line to mask. We created this mask before. Yes, you see, this is blank image. So we are drawing path to this mask. And here you can see we are adding our original image with this mask. So by doing that, we have some paths in original image. You see this is FPS calculation. We are displaying our image. And here we are updating our old gray frame and we are reshaping our point so that we can pass it to Lucas-Kanade method. And I think yes, this block is like this, and if if point cannot be found, P0 is equal to none. And we have one more if statement here. If point is out of the image, full image, we are setting P0 none again. Yeah, there's one more. Yeah, you will understand this block in 10 seconds. I want to show you video because it's otherwise it's hard to understand. Again, we will track this, so you will understand it now. This is our target point. We are tracking this, but when it goes outside of the screen, you see the new point is detected. This block is doing that. Of course, you can remove this block if you don't want to track feature. If feature is disappear from screen, that might be better for you. I don't know. You can just directly display image without finding new point and creating mask. Up to you. Yeah, this method is basically like this. First, we are drawing rectangle. This is our target object, and from this target object we are detecting corner points, and for each frame we are trying to track this specific point. Let me show you a few video. For example, streets. Let's try to track some people. Yeah, for example, this man. I'm drawing rectangle again. This is my target object. Let's see coordinates. You see. So here we are detecting all the points from full frame, and if points are false between this rectangle, coordinates of this rectangle, we are saving these to selected point variable. And in third step, you see the selected feature. We will try to track this for each frame. And in third step, we will try to track this. Show you. Yeah, you see. For each frame, algorithm tries to track this feature, and we are drawing mask. We are drawing path with mask. Yeah, you see the mask. Where is that? Where is mask? Here. So using old point and new point, we are drawing line. So it looks like mask. But this, this pipeline has some restrictions. For example, when the camera is moving, it's not that good. Let me show you. For example, this video. Yes, this is our target object. So you see the selected point. We will try to track this. So you will understand. Yeah, when camera is moving, you see the point is kind of going backwards, but it's not the case. But because camera is moving, there is nothing that we can do. So you can use this code when camera is not moving. For example, this in the street video, it works perfectly because camera is static. Let me try to track another people. For example, this one maybe. Let's see the feature. Yes, we will try to track this. Yeah, you see, perfect. And FPS value is, I think it's really good. Yeah, not that good, but 30 FPS is okay for most of the time. Yeah, I think that's it for this video, or should I say anything else? Yeah, thanks for watching. See you soon.